Hi, Mr. Ko here, and today's topic is solving special systems. And our goal for today is we're going to solve special systems of equations. And our California standard for today is Algebra 9.0. Alright, so the main thing that I need you to make sure that you have as part of your notes is you have this particular chart right here. And this kind of gives you the classification, or basically tells you what type of special type of systems that you might have whenever that you are solving for your equations. So you have consistent independent, which means there's only one solution. They have different slopes, and that it looks something like this. So when you have one line going this way and another line going this way, that is called consistent, and it's independent because you only have one solution. Okay? Then you have another one where there is a consistent dependent type of system, and that basically is just the same line. And the same line means you have all solutions, everything, infinite, because basically you've just drawn the same exact line. And then you have one more, which is inconsistent, which is there's no intersection, okay? You basically have just drawn parallel lines. And there is no solution whatsoever because they're never ever going to touch, okay? So those are the three types: consistent independent, one solution; consistent dependent, many infinite solutions; and inconsistent is no solution whatsoever. Alright, so we're going to go ahead and go through how to determine your types of solutions. And this is a pretty easy lesson because all you're really going to do is change everything to your y is equal to mx plus b slope-intercept form. Then you're going to use the chart if you have it handy. If not, just kind of remember, independent is 1, consistent dependent is all, everything, and then of course inconsistent, nothing. Okay, so your type of systems, and then we're going to classify it. Okay, alright, so here we have two systems of equations, and we're going to go ahead and solve them. The first thing that we want to do is just change them both into y is equal to mx plus b. Our first one is already done, so we're good here. We're not going to worry about that. Now let's go and change this one. So this, I'm going to move this over to this side. So if I move it over to this side, I'm going to add 2x and add 2x. I now have y is equal to 2x minus 3. And then now, I just have to go ahead and check this one and check this one. If you look, they're the same exact line, which makes this a consistent system. So this is consistent. And because this line and that line are exactly the same, this is called a dependent. Alright, and that's basically all you have to do for today. So change them to y is equal to mx plus b form, or your slope-intercept form, and then figure out what type of system they are, and then classify. They're both consistent and dependent. Alright, let's do another one. Okay, so here we have 3x plus y is equal to 4, and we have negative 3x is equal to y minus 7. So let's go ahead and first of all make them into the y is equal to mx plus b format. So let's take the first one. And if you notice, it's 3x plus y, so all I'm going to do here is just move the 3x by subtracting it, and then I'm going to rewrite this one. So if I rewrite this one, that's going to look like y is equal to negative 3x and then plus 4. So plus 4 because that's a positive 4. Okay? Then, let's take this one, and I'm going to go ahead and rewrite this one again. If you look at it, y is already technically in the mx plus b format if I were to just take over and move the 7 over. So let's just go ahead and do that. If I go ahead and add 7, I'm going to rewrite this particular one, and that comes down here. That's going to look like y is equal to, oh, you know what, I'm going to write it in the standard format of how you see it. So here, it's y, because I got rid of the 7, and then on this side, it's going to be negative 3x plus 7, okay? And yes, even though the y's are on opposite sides, it doesn't matter because you're still equal to each other, okay? So if I rewrite this, it would still be y is equal to negative 3x plus 7. And if you look at it, they have the same slope. And we learned that the same slope means they're parallel. If they're parallel, that means you're going to have two lines that'll never, ever, ever, ever touch. So this is called inconsistent. Okay, and that's your classification for whenever you have these two particular lines that have the same exact slope, but they have different y's. It basically is like that, okay? Alright, let's try another one. And at any time, if you don't see it right away, graph them out. If you graph them out, way easier too. Alright, and our final one, let's go ahead and look at this one. So this is already in our y-intercept format, which is our slope-intercept format, which is perfect, so we're going to leave it. This is not, so we're going to go ahead and shift things around, okay? What I see here is I see a negative y minus 6. I'm going to go ahead and move this y over to this side. So if I move it over to this side, I'm going to have plus y, okay? I now have 4x plus y is equal to negative 6. And again, even though it's minus 6, you're going to continue with it. You're going to keep it. I now have to move this 4x over by subtracting 4x. Subtract 4x. I now have y is equal to negative 4x minus 6. And that is our second part right here. So all of this became this. Now all I'm going to do is I'm going to take this and compare it with this. Notice that I have this and this right here. And it looks like that they have the exact same slope. So, which means this is going to be, again, inconsistent. Okay? All right. Alright, if you'd like to see more videos, go to www.youtube.com/user/tycodad, and that's it. Have a great day. Thanks.